Yeah, thank you so much for the invitation, and it's really an honor to present and meet everyone here. So I'm Kelvin Chen from Google DeepMind. Since I joined Google, I have been working on the image generation models, such as Imagen from earlier days, and the recent two models, Nano Banana from 3 months ago, and Nano Banana Pro last week. So yeah, given my background in this talk, I will talk about how people use image generation in the past and how we developed the latest model to make sure we achieve what people need to do in present, and in the future, what we like to achieve to make it better. So before going into the main topics in this talk, I would like to show you some examples of how people are using image generation nowadays. And below are some examples from Nano Banana Pro, which is released last week. So the first application is, of course, image generation. Imagine that if you want to prepare a PowerPoint slides and you want to get something like this, a clock tower and sunset. So in the past, you would just go through Google image search and then type a clock tower and sunset and then do a lot of searching and then find a good image and then put it in the slides. But then now with a text-to-image model or very sophisticated image generation model, you can simply type a clock tower in sunset, and then in seconds, the model will generate an image for you with nice aesthetic, nice color tone, nice composition. So it saves you lots of time to do this kind of preparing different material. So here is another example, which is a natural extension of image generation, which is image editing. So if you can recognize, this is me in Japan. So when I want to do some creative edits, for example, I want to turn myself into a 1990s rock star, and then I can just turn this image into a 1990s style. And then you see that the model automatically helps you to turn the image to a bit more yellowish to make it more vintage feeling. And at the same time, it changes my hairstyle and my outfit to make sure, yeah, I look like a 1990 rock star. And the best thing here is that the model knows that the background, for example, the deer here, should not be changed. So it knows what you want to do, and it helps you to save you a lot of time to do manual editing, for example, in Photoshop. So it comes to something that is more recent. So here's an example. Imagine that you are a teacher, and you want to teach a student about our solar system. So what were you doing in the past? You just, go to Google search and then gather important material, and then you will find good images or good graphics, and then you try to compose it in a PowerPoint slides, and then you need to make your summary by yourself. You need to go through all the material and make a good summary before you can make the slides. But then with image generation nowadays, you can do this. You can just type, explain the solar system for me. And then in like 10, 20 seconds, the model automatically generates something for you. You don't need to do any research. You don't need to go through Google search, Google image search, anything. You can just do it in seconds. And let's go one step further. So if I want to do something more personal or less common, so usually you also need to go through Google search for extensive time. For example here, I want to do some summary of my PhD works about video super resolution. So in the past, what I do, I will just go through Google Scholar, type my name, and then I will find some video super resolution papers. And then I will just go through the papers, read the abstract, introduction, and everything. And then I get a nice summary of my papers. And then I know that what material should be in the slides. But then I need to spend more time to create graphics like this. For me, I'm a person with zero artistic sense. If you want me to generate slides like this, yeah, it takes me years, I think. Yeah, but then nowadays, I actually did that a few days ago. I just typed summarize Kelvin Chan's video super resolution papers. And then in 20 seconds, the model generates something like this. And if you really don't like the style, you can just prompt the model, change the style to something else. Then you can automatically get another style. So I think this kind of model unlocks a lot of creativity and also capability, because many of us in the past will just spend time so polishing our slides, even though if we have very good ideas, we need to spend lots of time to polish it, to make it presentable. But then nowadays, we don't need to do that. We can focus on our ideas. We can spend more time on polishing our thoughts instead of graphics. And the rest, the model can do it for you. And then let's go to something more sophisticated, which is reasoning. So many people think that image generation model is just a get better by drawing pictures better. But is it really the case? For example, if we want to do something like this, I want to solve a word puzzle like this. So in the past, we would just go through each hint one by one. And then after you get some candidates, you will just check whether each candidate is compatible, and then you take hours to solve this. But again, if you have something like this, and then you just ask the model, solve this for me, and then in 10 seconds, and then everything is solved. So this kind of sophisticated image generation model not help you to generate better images, but at the same time, it helps you to solve different problems. So yeah, I think all of you already have a rough sense of how generation model is helping us nowadays. So let's go back to the original topic. So in my perspective, in the past, image generation is like a toy. So you play with it, you have a lot of fun, it gives you nice images, and then that's it. And then we come to the present. We now have a much better models. It will surprise you like a slot machine. When you try long enough, then you'll get good results. But then you need to spend a lot of time doing trial and error until you get what you want. So in the future, we want to build something that is not a tool. It's a partner with you. So imagine that when you ask your collaborator to do something for you, you don't want to check everything for him. You assume that he or she will do the job well. But at this stage, at present, when you ask the model to do something, you always have to check if the model is doing something correctly. But in the future, we don't want to do that. We want to assume that the model is capable of doing the job well. So this is our ultimate goal. So let's talk about each stage in more details. So in very early days, I think all of you also know, image generation is like a task-specific model. For example, if I'm given a ring image and I want to remove the ring in the image to reveal more details in the image, so I will use ring removal AI to do ring removal. But the problem is that this ring removal model cannot be extended to other tasks. That means if I want to do scratch removal this time, I need to use another model to do this. And these two models cannot be generalized to other tasks such as colorization. So imagine that you have 10 tasks out there, and you need to develop 10 models to do that. But the problem is you do not have 10 tasks only. You have 100, or even there are lots of tasks. So it is not a scalable approach to develop one model for each task. And the second problem of the models in the past is that it generates images with nice quality. For example, here, you see that if I want to generate a rock in a glass of water, so the quality is very good, right? But I think all of you know what's the problem of this image. The problem is the rock shouldn't be floating in the water, assuming that the density, everything is normal. So the problem is that you can play with it. It's very fun to have images like this in seconds. But then if you want to really use it for productivity or want to generate something that is trustable, you cannot rely on the model in the past. So given these problems, so our team at Google wants to generate something that is trustable, reliable, and you can play with it with fun, and then you can use it also with productivity. So you can see the difference here. So when you use, this is an image from Banana Pro. So if you want to generate an image of a rock inside a glass of water, so the model now knows that the rock should sink in the bottom of the water. And also, For example, in Nano Banana and Nano Banana Pro, our models become a general model. That means we don't need to use one model for rain removal, one model for scratch removal. Instead, we can use one model to do everything, basically everything. For example, generation, reasoning, and also editing. And also the quality becomes much better when you compare it with the previous models. But there are some problems existing here. So as I just mentioned, it's more like a trial and error game, because when we use the model right now, so it's more reliable comparatively, but then it isn't fully reliable. So take this as an example. We have a dog here, and then we have a very simple task. We want to add a head to the dog. And then the first trial, we get something that is a cartoon-ish head, which is not very convincing because the style does not match. And then we'll just go back and then try again. We'll just add a head and then run again. And this time we get a realistic head. But then it's floating. So it's not a very good image neither. And then we'll go back again, and then we'll just generate again. And then now we get a head. So it's like a trial and error flow. So essentially, when you want to generate something, sometimes we are spending more time in curating good examples than generating images. So this is one big problem here, and this is one problem we want to solve. Another problem of current model is that sometimes it will do something that you do not want to do. For example, given this original image, and I want to change the hair to blonde, and you see that it's very good. The hair color changes. But then when you look at the background, it changes. But we don't want that. And also, if you look carefully enough, the color of the eyes also change. So the problem is that you really can't trust the model, because I only want to change the hair color, but essentially I need to check whether it is doing everything correctly. I change those I want to change, but the model doesn't change anything else. So that's why it's not super reliable. So we have talked about the models in the past and in the future, in the present. So here is some thoughts of myself of what the future generation model should be. So in the left, we see that this is the current workflow. You give the model an input, which is an image or a text or both, and then the model will generate something for you. And then you check whether this image is correct, everything, and then if it is correct, then go ahead. And if it is not, then do it again. But then the problem is, I've just mentioned it's not very reliable, and that's why we want to do something in the right. That means you pass something into the model will generate something for you, of course. But imagine that what your collaborator will do. It will double check his work to see if the work is correct, and then if it is correct, it will pass it back to you. So we want to do something similar. So after the model generates something out, and then it will do a self-critique or checking stage to make sure what it generates is correct. And then if it is not correct, it will refine it, and then it will give you the output. And then if it is not correct, then it will just go through the entire process again until it gives you a correct image. That means we want a model that is not hallucinating at anything. It's starting to reason and then to generate something that you need. So this is a very concrete example. Imagine that I want to generate an image of a hand with 5 fingers. Then the first image the model generate have 6 fingers. So in the past, the model will just output this for you, and then you need to go through it again to generate until you get a good image. But then what we hope is that after you generate the image in the left, the model will check whether the image is correct. And then, for example, here, the model detects there are too many fingers in this. And then it revises and then gives you the final output. And this is how you can trust your model, because you know that your model will check the output of itself until it gives you the correct image. The second quality or capability I think the future model should have is factuality and knowledge. Because you can imagine that a good model or good, reliable collaborator should have enough knowledge about the world. So imagine that if you want to generate an image in 1888, because many of our training data nowadays, because we take photos with a complete Eiffel Tower. So if you want to generate an Eiffel Tower, many of the previous or older models will generate something like this, because the model is biased to a complete Eiffel Tower. But it actually ignores the fact that Eiffel Tower is not completed yet in 1888. So a reliable model should know that in 1888, the Eiffel Tower isn't completed, and I should generate an Eiffel Tower that is not completed. That means they are not just generating or dreaming something for you. They are doing research, and then they will give you something. And that's how you get trust between you and your model. And then it comes to something more, which is intelligence. So in the older models, when you ask the model to solve a very simple Sudoku here, the model basically doesn't know what to do. Maybe it sees that, oh, there are numbers there, so I should generate some numbers. But then it doesn't understand the rules of Sudoku. But then the future model should be intelligent enough to understand what the problem it tries to solve. For example, in Sudoku, it should understand that, okay, this is a Sudoku. I need to follow the rules. That means all the numbers are not repeated, and to give you something like this. So I think with those capabilities, models can do much more. So imagine that you are given this problem, a chain of gears, and then you are asked, the first gear is rotating clockwise, and then how would the other gear moves? So we as a human, we would have a picture in our mind that, okay, they're connected together. So they should be one clockwise, one anti-clockwise, one clockwise and anti-clockwise. But without those image generation model, the current model is difficult to picture this. So what I think is, if you have a good image generation model, you can accurately understand what the user wants to solve, and then you can generate the corresponding images. And with images, it helps you to solve your problem. But of course, the prerequisite is that your model should be intelligent and accurate enough to generate images that you want. So with this thing, it would be very helpful to solve more complicated more complicated problem in the future. For example, if you want to solve a very complicated geometry problem. For example, in our primary school years, you also want to draw some lines to solve some geometry problems. Maybe this is helpful for some more complicated problems. It helps to visualize the problem, to understand the problem, and then to solve the problem. And after all of this, what we want to achieve is interactivity. That means we should have a model that understands everything. Maybe this is something like the role model people are saying. So we don't want an image that draws nice pictures. We want an image that understands the world. For example, here, if I want to move the light to the left, so you need to understand the physics between them. For example, the lighting of the room should change, and also how do the lamp interact with the floor. So a good model should understand the physical property of the world instead of generating nice images. So yeah, I've talked about so many properties or qualities a future model is, but with better model, you have greater power, and you need to be careful of what you can do. So here are some thoughts about the models in the future. The first thing is, of course, privacy. Nowadays we are training our models with lots of data in the internet, but what we need to be careful is that we should use data that is legal or compliant. That means you shouldn't be using any private information to train your model, to make sure that the trained model are not violating anyone. And then the second one is very common, which is bias. So I think many of you have already heard that some models in older days will have a lot of bias towards, for example, gender, race, and ages. So with a powerful model, we also need to make sure that we don't have a bias towards any of these, to make sure that no one is offended, and to make sure a fair use between everyone. Now, and then finally, it is transparency. So we need to make sure that people know what you are building, what you are giving people, because when people want to trust your model, they need to know what your model is. So we need to be transparent. We need to let people know how we obtain our model and then how they can rely on our models. So this is a very important aspect of our model in the future. So, yeah, here is a very brief summary. In the past, we are doing one trick for each model. It is very good, but it is single task. It's not scalable. And then that's why we want to build. That's why we build Imagen. We build Nano Banana Pro. So we have much better quality right now, but we still need to go through this trial and error process, and it is unstable, and you cannot trust it. And in the future, we would like to build a reliable partner. That means, as I've said, you can trust it without double-checking anything. You can assume that the work is done correctly. And it can do reasoning, it has self-awareness, and then it can self-correcting itself, and then you can trust it. So, yeah, this is the final thought. So, in the past, people like me cannot present our ideas well because we don't know how to draw, we have no artistic sense. So assuming that if you want me to generate a slide like this, I will just paste all the text here over a white background. So, but then with this kind of image generation model, our limit becomes our creativity itself, our idea. That means you don't need to draw beautiful ideas to present your ideas. You can have good ideas, and then you can ask the model to generate something for you. So, and this is the final remark. So can you see that actually there are Gemini logo at the bottom right corner? Actually, this slide is generated by Nano Banana Pro. So the entire content here, I did not create any graphics for you. So basically, this is from Nano Banana Pro. And the material itself is from Gemini 3. So you can imagine that with proper use of these tools, you can save a lot of time. So in the past, it would take me years to design some beautiful slides like this. It is not perfect. I need to take some time to iterate with the model. For example, if you go back to this example, at the very first iteration, the image in the middle, it has only 5 fingers. And then I need to go back to the model and tell, okay, the image in the middle seems correct. You need to adjust it to make it incorrect to present my ideas. So that's what I mean. It's not perfect. You need iteration with the model. But yeah, it already saved me a lot of time. It takes me only 5-6 hours to present this slides. But then in the past, it would take me weeks. Yeah. So yeah, that's what I want to say. And then I hope you enjoy the talk and have a better sense of how people can use image generation models in the past, present, and in the future. Yeah, thank you.